Here we have a modeling question involving differentiation. These are quite common and they are very quite standard in the approach that you take to solve these questions. So the question reads, a cylindrical biscuit tin has a close-fitting lid which overlaps the tin by 1 centimeter as shown. So let's take a look at that. We can see what's happening here, what it's referring to. Then it goes on to say the radii of the tin and the lid are both x centimeters. We can see that's given to us in the diagram. So we've understood those sentences, all of that information, and that is already in our diagram, which is good. If it wasn't, then I would go and draw that in the diagram to help me solve the problem. The tin and the lid are made of a thin sheet of metal of area 80 pi centimeter squared, and there is no wastage. So that's really important information that we're going to need to use. And it tells us that the volume of the tin is V centimeter cubed. So then it goes on to say, show that V is equal to this. It's a show that question, which means we need to get to this answer. It's saying show that V is this. Now we know V is representing the volume. So we're going to go and first of all set up an equation for the volume of this tin using our knowledge of cylinders. So volume of a cylinder is equal to pi r squared times h. And here the radius is represented by x, so we'll say pi x squared times h, which we don't know. It's not given to us in the question. So this here, I'll label as h. Now, that might be all good and well. We found the volume equation, but as we can see, the show that volume equation has no h in it. So we need to find a way of eliminating this h. So we need to form a second equation, which is always the case. If you want to get rid of an unknown, we need another equation involving that h, and then we can substitute that in. So a second equation, what could we possibly use? We've used the volume. Notice here it mentions that the tin and the lid are made of a thin sheet of metal of area 80 pi centimeter squared. So that's the area, and there is no wastage, meaning all of that area, 80 pi centimeter squared, is the area or the surface area of the tin as well as the lid. So we're going to go and have to form an equation for the surface area of both the tin and the lid. So let's go and take a look at the lid first. What is its surface area? So I'll write down surface area is equal to, well, it's made up of a circle, so it's got pi x squared. And then we've got this curved surface area, which is this bit here of the lid, which goes all the way around. And that surface area is essentially the circumference times that height, 1. Because if you were to open that up, that would be a thin rectangular strip. And that length along the top will be the circumference, which will be pi times diameter, which is 2x. So that's our circumference, pi times 2x. And that length here was 1. So the area there is pi 2x times 1. Which is just 2 pi x. So that's the lid surface area. Then the tin, remember the top of the tin is open, but there is a base which we need to consider. So the surface area of the tin is the base circle, which is pi x squared, and then plus this curved surface area, which goes all the way around. Now, if we were to open that up, it's same kind of thing here. It forms a rectangle, and the length of that rectangle is the circumference, which again is pi times diameter, and the height is obviously h. So the area of this curved surface area is 2 pi xh. 2 pi xh. Now the total surface area is 80 pi centimeter squared. So we need to add these up here. So if we add these up, we get total surface area, which is equal to 2 pi x squared plus 2 pi x plus 2 pi x h. And we know that this total surface area was given to us in the question. It's 80 pi. So we can go and then say 80 pi is equal to 2 pi x squared plus 2 pi x plus 2 pi x h. Now the question was to show that the volume is equal to that, which has no h in it. So if we want to eliminate h from this equation that we obtained here, we need to find the second equation which we have, which is here, and we're going to have to rearrange this for h and substitute it into the first equation. So let's go and take a look at that. We're going to go and do that right now. So we have, just tidying this up a bit here, we've got $80 pi minus 2 pi x squared minus 2 pi x, all divided by 2 pi x, is equal to h. And that's what we're going to substitute into our first equation. So substituting this h into our first equation gets us v is equal to pi x squared times h, which we know to be 80 pi minus 2 pi x squared minus 2 pi x, all over 2 pi x. Let's tidy things up a bit here. So divide both the numerator and denominator by pi. We can also divide both the numerator and denominator by x. And we can also divide both the numerator and denominator by 2, leading to x 40 pi after we divide that by 2 minus pi x squared after we divide that by 2 minus pi x. And then if we get it into the form that is given to us in the show that part, we want to take pi out as a factor and multiply the x which is outside here. So we end up with 40x minus x cubed minus x squared. And that looks nearly like that, other than the fact that the x squared and x cubed terms are in different positions. So let's just get it into that position. 40x minus x squared minus x cubed as required. So that's part A of the question. Now that's a show that question. So whether you can do that part or not, you can go and do part B using that result. So given that x can vary, use differentiation to find the positive value of x for which v is stationary. Now the word stationary should trigger in our mind that we're looking at a stationary point. This is where dv by dx is equal to 0. So let's go and first of all find out what dv by dx is. So for part B of the question, we'll go and write down our equation. V is equal to 40x pi, I'm timesing everything by pi, minus pi x squared. Oops, let me just write all the number terms at the beginning. So we've got 40 pi x squared. So let's go and write down our equation v. We'll multiply everything by pi to get it into the form which is standard, so we can use standard differentiation methods. So we have 40 pi x minus pi x squared minus pi x cubed. dv by dx is then 40 pi, which is the constant term, minus 2 pi x minus 3 pi x squared. And we know that at the stationary point, this is equal to the dv by dx is 0. So we've got 40 pi minus 2 pi x minus 3 pi x squared equaling to 0. Since this is equal to 0, we can divide both sides by pi, and that then gets us 40 minus 2x minus 3x squared equals to 0. So we've got a quadratic equation here. We can go and find the x values by simply using our function on the calculator, the equation function. And in the equation function, if we go and write down the coefficient of x squared, which is minus 3, coefficient of x, which is minus 2, and the constant term, which is 40, that then gives us an x value of 10 over 3, and a second x value of minus 4. Now, in the context of the question, x is a dimension, a length, therefore x cannot be negative. So we cross that out. So this is the correct x value that we've got. The question says use differentiation to find the positive value of x for which v is stationary. So there's our answer. Part C of the question. So part C then goes on to say, prove that this value of x gives a maximum value. Now we know maximum value is when the second derivative, when d2v by dx squared is less than 0 for maximum. So let's go and write that down first, since that's what we're trying to show. So let's go and find the second derivative. So the second derivative, d2v by dx squared, is equal to minus 2 pi minus 6 pi x. Now the x value is 10 over 3, so go and substitute that, minus 2 pi minus 6 pi 10 over 3. And we can see here both of these terms are negative, so the answer that we get is going to be less than 0. Let's write that down what it's going to be anyway, minus 2 pi. And we have 6 over 3, which is minus 20 pi, which is equal to minus 22 pi, which is less than 0. Therefore, maximum. And then part D says find the maximum value of v. Now we have the x value at which this maximum occurs. So we simply need to go and find this maximum value of v, i.e. the volume. So we go back to our original equation for the volume, and we're going to then find out what the volume is at this point. So here's part D. V is equal to 40 pi, and the x value that we're using is 10 over 3 minus pi 10 over 3 squared minus pi 10 over 3 cubed. And so tidying this up here, we get 400 pi over 3 minus 100 pi over 9 minus 1000 pi over 27. And so if we then type all of that in, we get 400 over 3 pi minus 100 over 9 pi minus 1000 over 27. And that gets us 2300 over 27 pi is the volume. We can write that in decimals. It's equal to 267.6 centimeter cubed.